Hello, integrated math students. During our class today, we took notes on polygons, names of polygons, triangle, quadrilateral, pentagon, all those things, and we're going to go into a lot more detail with many of those types of polygons over the next couple days. But what we're going to do right now is focus on triangles and just review, I think you've heard these before, but just review names for special types of triangles and talk about ways we can classify triangles. So, in your book of notes, we're going to finish up the section 6.2 notes. We're on page 72. So I'm going to make the video pause for a moment, make sure your notes are out, and open to page 72. So we're going to look at naming triangles, and there are two different ways we name every triangle. We name triangles by information about their sides and information about their angles. So really, every triangle we will give two names to. One name that has something to do with its sides, and one name that has something to do with its angles. So the first thing we'll deal with is the three names we can give triangles that have something to do with its sides. Name number one, a scalene triangle. In a scalene triangle, all sides and angles are different. All sides, and therefore at the same time, all angles, are different. In a scalene triangle, all sides and angles are different. So I'm going to draw a triangle. Looks like all these sides have different lengths, but there's a particular way we're going to mark this triangle. In the notes from class today, we talked about regular polygons where all the sides are the same, and I put tick marks on all of them to show they were all equal. Well, to show here that the sides are all different, I'm going to put one tick mark there, and two tick marks there, and three tick marks there to show all those sides have different lengths. Please make sure this is in your notes. Our second way we can name a triangle according to the sides, is an isosceles triangle. An isosceles triangle. And in an isosceles triangle, two sides and angles are congruent. Two sides, and for that matter, angles, are congruent. And as I think I mentioned today in class, congruent is our special geometry word for basically equal. Means a little bit more than just equal, which we'll get into over the next several weeks. But for right now, we can consider it to be equal. So to give you an example of an isosceles triangle, this side and this side will have the same length and will be different from this side. At the same time, two of our angles will be congruent, so I can mark that angle and that angle with one little arc mark. I can show it's different than that one. Wow, that's a little bit tricky to see. I was trying to show two little arc marks there. Well, I'll do it like that. Two arc marks on the top. An isosceles triangle, two sides and two angles are congruent. Scalene, they're all different. Isosceles, two of them are the same. The third one's different. Make sure this is in your notes. One more name to name triangles by their sides, equilateral. In an equilateral triangle, all sides and angles are congruent. All sides, and for that matter angles, are congruent. All sides and all angles are congruent. To show all the sides are the same, tick mark, tick mark, tick mark. They're all the same. And to show the angles are all the same, something like that. Make sure this is in your notes. There is sometimes another name we would give these triangles. Equilateral. Lateral means sides. All the sides are equal. Well, if all the angles are also equal, another name we can give it is equiangular. All angles, which will also require all sides to be congruent. In an equiangular triangle, all angles are congruent. And actually, there's more to it than that. If all the angles are the same, and we know that our rule with triangles is the angles always add to 180 degrees, if all three angles are the same and they add to 180 degrees, what will each angle have to be if it's an equilateral or equiangular triangle? Any thoughts? Well, if I take 180 and divide by 3, all angles will be 60. This will be 60, this will be 60, this will be 60. They're all the same, and at the same time, they're all adding to 180. These are our three ways we can name triangles looking at their sides. Scalene, everything's different. Isosceles, two sides are equal. Equilateral, all three sides are equal. No sides equal, two sides equal, all sides equal. We'll practice with these names in a moment. But the other way we can name triangles has to do with the angles that they have. And you know these names, but maybe didn't apply them to triangles before. In an acute triangle, all the angles are less than 90 degrees. All angles are less than 90 degrees. Maybe we have a 60, a 70, and a 50 or something. That would be an acute triangle. All the angles are less than 90 degrees. Get that in the notes. Then we have a right triangle. In a right triangle, one angle equals 90 degrees. We have one right angle. I can only have one because if I had two, 90 plus 90 is 180, there'd be no degrees left for my third angle. One angle is going to be 90 degrees. Make sure that's in the notes. One more. If we have an acute triangle and we have a right triangle, we can also have an obtuse triangle, where one angle is greater than 90 degrees. Please copy this in your notes, and then we're going to practice with the side names and the angle names. Okay. Can you please get out the sheet titled Chapter 4, Practice Worksheet 7 that you should have gotten in the packet of papers you got last week in one of your classes, or handed for me on Monday. And if you were not in class last week or Monday and did not get these papers, you're just going to follow along and play along on the screen. Every triangle we're going to name in two different ways. We're going to name it according to the sides. And remember, our names are scalene. No sides are the same. Isosceles, two sides are the same. And equilateral, all sides are the same. And remember that our angle names are acute, right, and obtuse. By the way, I don't think I'm going to use the sheet the way it was intended. I think rather than trying to fill in lines over here, we're just going to go triangle by triangle and come up with their two names. Scalene, isosceles, equilateral for the sides, acute, right, obtuse for the angles. All sides are different, two sides are equal, three sides are equal. All acute angles, a right angle, an obtuse angle. We're going to do one or two together, and then you're going to try several on your own. In letter A, okay, I need a side name. I see 38, I see 52, and I see 46, which means all sides are different. Because all sides are different, would I call it scalene, isosceles, or equilateral? Because all sides are different, that's going to make it a scalene triangle. Next, look at the angles. 45 degrees, 58 degrees, 77 degrees. Would I call this triangle acute, right, or obtuse? Well, because all my angles are acute, I'm going to call the triangle acute. It is, I think we usually put the angle name first, but it doesn't matter. It is an acute and scalene triangle, or a scalene acute triangle. Either way would work. Sounds better to me saying acute first, whatever. Letter B. My sides, I have 33, 54, 54. Scalene, isosceles, or equilateral. And if you need to keep those notes up, by the way, absolutely have those on your side. What would we call it? Scalene, isosceles, or equilateral? Well, I think two of the sides are the same. I think that's going to make it isosceles. As for the other name, 36 degrees, 72 degrees, 72 degrees. Acute, right, or obtuse. Since all the angles are acute, we're going to call this an acute isosceles triangle. No, you don't need to put the triangle symbol at the end. Okay, letter C. Scalene, isosceles, or equilateral. 32, 52, 61, they're all different. It's scalene. Acute, right, or obtuse. I see a right angle, so I'm going to call this a right scalene triangle. And I think in the future I'm going to ask the angle name first so we can write that first, and then we'll look at the side name. Oops, you can't see the triangle part. The triangle's at the end. Let's look at letter D. Let's do the angle name first. Acute, right, or obtuse. 60, 60, 60 looks acute to me. Scalene, isosceles, or equilateral. 39, 39, 39, all the sides are the same. This is an acute equilateral triangle. What about E? Acute, right, obtuse. I see an obtuse angle up here, so I'll call it obtuse. Scalene, isosceles, or equilateral. 47, 47, 76, two of them are the same. That makes it isosceles. This is an obtuse isosceles triangle. See if you can do both names for F. 38, 42, 100. That makes this one obtuse. 41, 45, 66. All sides are different. It is obtuse and scalene. It's an obtuse. Oops, that's off the page. Sorry. An obtuse scalene triangle. Go to letter G. Come up with the two names for G. I see a right angle. That makes it a right triangle. And 26, 150, 152, they're all different. It is a right scalene triangle. Right, scalene triangle. Do letter H. Um, 62 degrees, 80 degrees, 38, they're all acute angles, so I'm going to call this acute. 37, 59, 53, all the sides are different. It is an acute scalene triangle. Two more. Letter I. I see an obtuse angle, so it's obtuse. 37, 37, 64 for the sides. It is an obtuse isosceles triangle because two sides, but not all three were the same. Last one, letter J. This looks acute. All angles are less than 90. And all sides are the same. It is an acute equilateral triangle. What I now need you to do to get credit for watching this video, although answering the questions was part of your credit, for the rest of your credit, you need to go submit a PDF of two different things to Google Classroom. You need to submit a PDF of page 72 from the notes that you took with all these names, and then you also need to include that practice worksheet 7 that we just did. And if you didn't have the worksheet, hopefully you just made notes on a separate sheet of paper and all of that. I will see you tomorrow, some of you in person, some of you online.